Hi, I'm Olivia Hill,
And I'm Mary Conn.
and today we're going to be talking about your carbon footprint.
What is your carbon footprint?
Carbon footprint is historically defined as the total sets of greenhouse gas emissions caused by an organization, event, product, or individual. About 3/4 of greenhouse gas emissions that humans use daily are from burning fossil fuels. These greenhouse gas emissions have been on the rise since the Industrial Revolution. Because the greenhouse gas effect no longer has its full effect, scientists have linked climate change, melting of glaciers, and the rising of sea levels to this cause. Food, and the factories and farms they are produced and packaged in, have a huge impact on the carbon footprint, also known as food print. 13% of U.S. greenhouse gas emissions result from the production and transportation of food. Buying food that was imported from other countries is a huge waste of fuel. It's better to support your local markets. While we cannot stop the negative effects of carbon footprint, we can slow it down. There are many ways in which you can prevent this mass effect. Most of them are easy and involve saving energy and power. Whenever you're not at home or not in a specific room, it's best to turn off all the lights so you don't waste energy. Turning down the heat in your home also saves energy and prevents the burning of fossil fuels in your heaters. If possible, solar panels are a huge help for conserving energy. And lowering or recycling the amount of water usage in your home helps not to waste anything. When possible, walk or ride your bike to your destination. Carpool or public transportation is also an option. For air travel, try to fly less frequently and to shorter distances so that the plane doesn't burn as many fossil fuels. Since the planes are in the air most of the time, when they burn that fuel, it's closer to the atmosphere and will have a faster effect than those coming from the Earth's crust.
Our carbon footprint is a huge concern because the amount of carbon that we take in and use is more than what we emit back. We are demanding more from the Earth than we can provide. In a 2013 survey, CO2 represented 84% of Earth's greenhouse gases. It also stated that each year the world uses 30 billion tons of carbon. The first graph shows what a typical person in a modernized country would use for carbon. The second graph shows the top 10 countries which use the most carbon of 2009. Does the amount of carbon on Earth affect biodiversity, and why should we as humans care? For a human's view, the rapid climate change and accelerating biodiversity loss endangers human security. Example, a major change in the food chain upon which we depend, water sources may change, recede, or disappear, medicines and other resources we rely on may be harder to obtain, as the plants and fauna they are derived from may reduce or disappear. Climate change is having a major impact on biodiversity and is predicted and proclaimed to become a progressively more significant threat in the coming decades. Loss of Arctic sea ice threatens biodiversity across an entire biome. The related pressure of ocean acidification resulting from higher amounts of carbon dioxide in the atmosphere is also already being watched. This next section, involving with technologies being created, is taken from an interview with scientist Conn. Ecosystems are already showing negative impacts under current levels of climate change, which is modest compared to future projected changes in addition to warming temperatures, more frequent extreme weather events, and changing patterns, or rainfall and drought can be expected to have significant impacts on biodiversity. To resolve this issue, Conn said, we need to take one of the links of this chain and negate it before it reaches the global warming stage. We're addressing the middle link, capturing carbon dioxide in the atmosphere. A common method of adsorption, the carbon dioxide physically bonds to a microscopic sponge-like solid surface. Releasing the carbon dioxide from the solid surface is much more cost and energy efficient than releasing it from a liquid medium. A hybrid metal and organic structure called zeolitic imidazoolite frameworks, or ZIFs, absorbs carbon dioxide molecules to its structure of metal ions and organic linkers. Through his research on ZIFs, Conn has synthesized a new subclass of ZIF that incorporates a ring carbonyl group. In its organic structure, given its vastly greater affinity and selectivity for separating and absorbing carbon dioxide, and a more chemically, thermally stable structure. In a simulation study, Conn conducted the new ZIF structure absorbed more than 100 times carbon dioxide than the other similar structures. With negligible difference in absorption of other gases, they can also separate carbon dioxide from gas mixtures more selectively. Seeing that vastly increased selectivity and capture capacity and its potential applications led Conzini to seek to protect the idea with a provisional patent which he obtained in October with the help of Lombard and the Intellectual Property of Technology Transport Office.
Remember, there are always ways to prevent the situation anywhere you go, such as when you're driving, in a plane, or in your home.
With CO2 now being declared a danger to human health by the U.S. EPA, it's a great threat as a greenhouse gas is given much importance as the leading cause of climate change and rising temperatures on the planet. The concentration of carbon dioxide in the atmosphere caused by the usage of fossil fuels has increased by around 40% since the beginning of the Industrial Revolution. As the level increases in the atmosphere and the oceans, we're getting farther away from the solution. How much can we safely emit is in conflict with how very much more we produce, especially in North America.
Well, I hope you learned something new today.
Thanks for watching.